Okay, that last video, it took way too long. I'm super sorry. All right, so here we go. So we have this example 7. Let A and B be sets in the universal set. So all we're trying to do is highlight where stuff should be at. That's all this is, okay? So then I have this. Does an intersection distribute over a union? That's the question, right? That is, does A intersection B union C is the same thing as this? So we're going to go highlight this side, and then we're going to go highlight this side. So the main thing, first thing, before we do anything, let's label our regions. R1, R2, R3, R4, R5, R6, R7, and R8. I'm going to label the exact same stuff over here. R1, R2, R3. I feel like you guys are going to be like, Miss Maxwell, I cannot believe you did this. And I'm at that point right now. Highlighter as well. Here we are. B union C. So here's the thing. Here's B. And I'm unioning it with C, so that means all of B and all of C. So I'm going to highlight all of this. And then here's the thing. I have to have it be an intersection with what? A. So if I come over here and I think about A, right? Where do they overlap? Where do I have that overlap? Right? I have it right here. So then I know that this side is R3, R6, and R5. So then this side is R3 plus R6 plus region 5. All right, the next thing to talk about is A intersection B. So let's highlight that. Tools, highlighter. A intersection B. So A and B's intersection is right here. And I have that. And then I have A intersect C. So A and C, the intersection is right here, what I'm doing. Right, there's the intersection. So here's the question, union. I would have to have all of my areas I have highlighted. I get the same stuff, which is R3 plus R6 plus R what? 5. Same stuff. So, yes, intersection distribute over a union. Yes. All right, so last one, inclusion, exclusion. So this is what it is, right? So if you have the number of sets in A plus the number of sets in B, then you need to minus the intersection. So they're saying this is what's going on. So this is region 2, region 3, and region 4. So region 1. This is all the same. Region 2 plus region 3. B is region 3 plus region 4. But you have region 3 twice, so you need a minus region what? 3, which is that part. Or another way to think of it is region 2 plus region 3 plus region what? 4. Which I prefer to think of it that way. And then it's going to be equal. So we do not count those elements what? Twice. All right, so we have this example. A Venn diagram is set up for us. Where set A is the face cards, right? So here are all face cards. Jack, King, Queen, Jack, King, Queen, Jack, Queen, Queen. So I have clubs, spades, and diamonds. And over here I have hearts. So that's set A is all face cards. Set B is a heart card. So here's all my hearts. So this is the only part of the overlap because my hearts face cards are going to go into the intersection. And then I have all my hearts. So I want to find out this. A union B, but I want to have a what? Number. So easiest way to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9. How many elements do I have here? 1, 2, what? 3. How many do I have over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, what? 10. So then, to get this, I'd go 9, because that's region 2. Add my intersection, which is 3. Add what I have over here in region 4, which is 10. When I add all those together, you get 22. And that's my answer. Done.